Okay.
Welcome everyone to Water Conservation Landscape Design Strategies. This is one of the webinars we are offering in our series, A Focus on Sustainability. This webinar series was developed by a group of organizations known regionally for their quality ecological education. By working together, the webinar series enables us to expand the reach of our individual programs. In case you're not familiar with our organizations, they're all nonprofit and largely volunteer groups in the United States. The regional groups are the Ecological Landscape Alliance, the Chesapeake Conservation Landscaping Council, the Midwest Ecological Landscape Alliance, and Eco-Landscape California. If you have any questions for the presenter, you may ask them at any time by typing in the question window, and we'll be holding your questions until the Q&A section at the end of the presentation. And now I'd like to introduce Gary Krause. His company, Gary Krause Landscaping, is certified in best management practices for sustainable landscaping from the Green Industries Institute, and his company specializes in sustainable landscape approaches. Gary holds a degree in landscape design and maintains a wide range of landscape certifications and is a certified sustainable landscaper. Gary has over 30 years experience in gardening, landscape design, construction, and maintenance. And he believes that the future for sustainable landscapes is very promising thanks to all of the new technology in plant genetics, smart water irrigation products, and other water conserving innovations. Welcome, Gary.
Thank you, Penny. So let's begin our presentation. Thank you, everybody, for attending. And my goal is for everybody to leave this webinar today with at least learning one new thing. And if I can do that, I feel very successful. So I'm Gary Krause. My business is Gary Krause Landscaping and Design. We are a certified sustainable landscape company. As Penny mentioned, I'm certified in sustainable landscaping and best management practices, in addition to having degrees in design. I've been working on this particular issue, sustainable landscaping, for almost 10 years now, trying to promote it and further its practices. So I'm hoping everybody will learn a little bit something, especially when it comes to landscape irrigation, because nothing lives without being properly watered, and I'm sure that we all know that. Okay, so moving right along, the first thing I want to talk about is when we are thinking about irrigating a landscape is, where does our water go? We really take water for granted, and that is something that that if you talk to people, your clients and so forth, they don't really perceive the fact that how water is used in the landscape and how efficient we can be in use of water management in landscaping. And as you can see from this chart, 58% of the water used in a household goes to the landscape. So the other majority is used by toilets, believe it or not. So if people really wanted to conserve water, they're going to look at their toilets and they're going to look at their landscape. Okay, moving right along. Climate change. We've all heard about climate change, and it's been a big discussion and very controversial in some arenas. But climate change definitely is affecting more out here in the West because of the droughts we're having, but it's impacting everywhere we look. And I think back east this winter you can see how hard the winter was and how much snow you had, how this climate change is affecting. So let's look at things to consider when it comes to climate change. Global temperature change, as you can see in this, from 1880 to 2000, you can see where we're actually warming up. And this is the, excuse me, let me go back on that. I think we can. Oops, nope. So that you can see from those charts that we are changing our climate, and we have to deal with it accordingly. Here's a good picture. I wanted to point out this picture to you. I've never seen anything grow on concrete. So why are we watering it? You know, it's kind of ridiculous to spend money on water to do this. And So being water-wise is a real issue when you're designing your landscapes. And as you see here, balancing our water budget, and water balance calculates inputs and outputs of the water on the site. So that's doing the math when you're designing a landscape irrigation system is extremely important. I can't emphasize it enough. And we'll get into some of the math here later on in the webinar. So, and then we should say, the other thing I want to point out here is a site should identify the goals for post-development water balance based on historical conditions and local or regional issues of concern. So, for instance, back east, especially the Northeast, water is not always a major issue as far as shortage of water, but what I want landscapers to and landscape designers to understand is it costs money to move water. You have pumps, and that takes a huge amount of energy to move water through sometimes 3 feet of main line to service the whole city. So don't think of water, conserving water, just as saving water and having more water available use. Also think about it as conserving energy. So you want to incorporate water filtration into the site design. Install a rain garden or a small vegetated catchment, or any area that it's possible to catch water and store it. In certain circumstances, it pencils out. So there's different sites that you can actually go to on the web to actually calculate roof surfaces and how much water you can get off that roof surface for storage. So you have to do the math because sometimes it's a economy of size. If it's not a big enough roof, you can't capture enough water, it doesn't pay to do that. Reusing water. Now, that's another good thing to consider in your design is, can you reuse gray water, or can you reuse any drainage water and divert that into a storage facility? It's not potable, but as long as you identify it as not potable, it's legal to use in most states, and it's a great way to help with conserving water and energy. And then lastly, clean and slow the flow of water, protect and enhance downstream water bodies. This is something that I find that most landscapers and designers don't take into consideration when they're designing landscape irrigations, because when you irrigate the landscape, you do cause some runoffs, especially if you over irrigate the landscape, and of course you're adding fertilizers and other products to the landscape, to the plants, phosphorus and phosphates and other amendments to the soil that actually can leach into the waterways and end up in streams and lakes and cause algae blooms. So it's always good to consider what we're saying here of vegetative swells or retention ponds, which I didn't put in here, but those are all good ways to design in a way to filter any water runoff. If you have large parking lots or whatever, that's something to consider. Okay, the plan. This is what we're going to get into as far as talking about how to set up an irrigation plan. Basically, you're looking at 2 plans here, and I want to ask all of you a rhetorical question, because I'm sure most of you already answered this. Which plan saves the most water? If you look at this plan on the left, it's all sprinklers, and you can look here, 1.9 gallons per minute. Here's 2.2 gallons per minute on each one of these heads. And so if you look at this plan over here, and only on the right, it only has a small little lawn area that has sprinklers in it. The rest of it is all drip systems, drip pipe and so forth laid out. So this plan on the left, and it has 1, 2, 3, 4, 5 valves, and the one on the right, it's not showing all the valves, I believe, but it would have at least 8 valves, 8 zones or more. And you can see here the precipitation rate, which we're going to talk about in a little bit. Now, those of you who don't know what that means, I'll explain it to you in the next few slides. For spray zones is 2 inches per hour. Water for 30 minutes. So you add all that up, there's a lot of water being poured on this landscape plan on the left. So moving right along here. Okay, developing the plan. So we want to have a process of how we go about getting the landscape plan designed. So the first thing most of us do that have been designing for quite a while is we'll develop the planting plan. That way we know where we need to put the water. So that, I want to talk about that a little bit here in developing the plan. Where to start, where to apply the water. Soil types. Now, I really want to advise everybody, please, please, make sure you understand and know your soil profile on that site and what you have to do to make sure that you don't get soil compaction, because with soil compaction you get a lot of runoff, and that causes problems because it's putting mud into the storm drains. So mud and dirt and bark or whatever you're using out there. So soil type is real important. So in the planting plan that you're going to make so you can develop your irrigation plan, you're going to want to look at how you're going to amend those soils, how you're going to make the soils more friable, and what type of plants you're going to put in those soils. Okay? So it's very important to identify the types of plants. If you're in a drought area, California, Arizona, New Mexico, and even here in Oregon, we have to conserve water. We don't have enough water. We're not getting it through the rain. Our mountains have no snow. So I'm going to plant natives in most of my landscape designs, but I'm also going to look for other types of plants that are more drought tolerant. In other words, they're going to use less water than a plant that like a rhododendron. They like wet feet. They like to be in wet, moist soils. And in the wild, the native rhododendrons grow at the edge of the forest canopy in all shade, and this forest floor stays very damp there. And then the next thing we're going to talk about is plant spacing and density. My belief is you don't need a plant in every square inch of that landscape. It's nice to have negative spaces where you have no plant. You may have some mulch or a few boulders. And in the design concept, you need a place for the eye to rest, because landscapes can get very busy with a lot of different textures and colors. So more is less in this circumstance. Always think about that. Less is more in this circumstance. Always think about that. I always advise my clients to plant as few as plants as possible when they first develop their landscaping, and then over the period of time, years, they can add a plant here and there. But people have a tendency, and I've seen landscape designers and contractors just put a ton of plants. 4 or 5 or 6 years down the road, you're coming back and pulling plants out, or some of the plants are dying because they don't have enough water to keep everything green, or there's water restrictions that affect that. So, and then the last thing we're going to look at here is lay of the land, your slope, your sun exposure, urban or rural property, and all these have different considerations when you're designing, especially when for use of water. If you're on a rural property, you're most likely going to be pumping out of a well. What's the gallons per minute out of that well? Is it you got a certified flow test, and if you only have 5 or 6 or 7 gallons a minute out of that, you're going to have to consider holding tanks. So that's all going to be part of your landscape design. Therefore, that's going to force you, even if you're in an area that has a lot of water, it's not drought restrictions there. You're still, if you're working off a well, you're still going to want to be conservative with water, because it costs that homeowner, that client, a lot of money to move that water from a holding tank to the landscape, and it costs a lot of money to build that. So it has to pencil out. Okay, so this is something I wanted to mention to you guys. This is Rainbird has a very good a PDF on all of this that I recommend that you go to their website and download it, and you can see their products that they're producing. I've looked at all the products. I looked at all the products that that we have here, and what we're looking at with Rainbird is the best water conserving products on the market. They're a smart controller. They have their subsurface drip tubing and things like that work excellent. So we use a lot of Rainbird products on our mainly because they have the best technology, and I've checked them all out. Okay, moving right along to our next one, engineering your system. Now, when I talk about engineering a system, exactly what I'm talking about is sizing your pipe, sizing your wire to your controllers, understanding your flow, your static pressure and your dynamic pressure coming off of your point of connection, and then what type of sprinklers you're going to use, the nozzles you're going to use on them, what type of controller, and whether you're going to need either moisture sensors or rain sensors. So this is an MP rotor that you can see on this slide right here, and you can see how this water how it puts water down. The MP rotor, and Rainbird also has one. I'm not real fond of theirs. I don't think they've got the technology on it just right yet, but I think that they will at some point. But Hunter produces the MP rotor. If you're not familiar with it, I'd highly recommend you doing some research on it. But this particular sprinkler puts water down so close to rainfall. It's really optimal. You're going to see lots of drops of water, and you don't get the misting with these as you do with the standard sprays and the standard spray nozzles. And I want to mention something about pressure on an irrigation system. Now that I brought it up, I'm going to talk some more about it, I think, later on. But you cannot irrigate properly if your pressure is not correct. You have to look at whether it's a rotor or a spray or a rotary nozzle and determine what the operating pressure of that particular nozzle is, and it must operate at that pressure. So you must either reduce the system overall with a pressure reducer to that particular pressure that's required by the individual sprinklers, or you can look into the Rainbird PRS, pressure regulated spray, and they have a 40 psi regulator built into the spray body that I highly recommend. That we look into and use, because I think it's an excellent device to use. The next one, this is a rotor. This is a rotor that we normally see in landscapes here, that on big lawns. Now you can see how the water is in this particular and how much pressure this needs to be. I would say that this sprinkler in this particular photograph is actually working under too much pressure. Now this next slide that you see right here is the Rainbird ESP SMT-E smart controller. This is the weather station and this is the controller. I've used them all and I'm certified in installing all of them, but this particular controller right here is the best on the market, mainly because this weather station is wired directly to the controller, and it has a tipping cup in there so it accurately measures rainfall. It will shut the controller off if you get 2/10 of an inch of rain, or you can adjust it upwards if you want. It will also shut off if the temperature gets below 40 degrees. So in a lot of cases, we don't even turn these off for the winter. Because they won't operate during cold weather. It also has a feature that can show you what the historical weather data is, what the next scheduled watering time is, and when and the current weather conditions. So it's a really great controller. We install a lot of these, and we haven't had any warranty calls on them. The next one is your soil moisture sensor, and this is a wired one. Toro has a wireless one. I have one. I haven't used it yet because we use these and I haven't had a need for it. But if you have an area that's very difficult to water, it's in full sun, it gets dry really easily, you might want to consider a soil moisture sensor, and you might also want to consider the Toro, a wireless one. Like I said, this is a wired one. This is a Rainbird, and you have to wire it to the controller. This is the Toro wireless one. I really like this because you just push this in the ground, and these spikes right here will detect moisture down to about, I think, 4 inches. And then this is the adapter that you put onto it. And then, of course, this is your rain sensor. And this this rain sensor here is a standard Hunter one. The other manufacturers have similar ones, but this just senses the rain. It doesn't measure it compared to the Rainbird one. It actually measures how much rainfall comes down. Okay, so moving right along here. This is the MP rotor performance data chart. You have to have this chart in front of you when you're designing, because every time you put a nozzle in, if it's a 90 degree or 180 or etc., you want to know what pressure you're going to have and what area that covers. So basically, we try to run all of our MP rotors off of 40 psi, and you can see here that this particular one right here is going to get you 10 feet radius at 0.23 gallons per minute, and this is your precipitation rate, inches per hour, 0.83. So if you took 0.83 times the number of sprinklers you had, this is going to give you your inches per hour, which is what you need in order to program this controller. Just remember, all irrigation, even the weather report, everything is calculated in inches per hour. So that's how rain falls, and when you get a weather report and said we had X number of inches, that was either in a 24-hour period or 1-hour period that you had X number of inches. So each one of these nozzles on that give you your information. So you need to have that while you're designing. Okay, I always tell everybody that works for me, it's always in the details. The devil's in the details. So every irrigation designer and consultant should always calculate every irrigation zone's pressure loss from each controller zone's farthest head back to the point of connection. So I'm pretty sure that most of you know what that means. It's not to just downstream of the valve, but in both directions. This calculation should be through all of the lateral and mainline pipings, remote control valve, backflow preventers, etc., to get an accurate pressure loss for each zone. So every time that water goes through a valve, goes through the backflow device, even goes through a fitting like a 90 or something, you're going to get some pressure loss. If you look at your Rainbird catalog or your Toro catalog or your Hunter catalog, they have formulas in the back, table charts in the back to calculate all this for you. So you just need to be able to punch those numbers into your design to calculate what your pressure loss is going to be, and then size your pipe accordingly. So if you do this for every zone, it will point out various problems within most irrigation system zone designs. So to assist you in recognizing these hidden problems, you should require any irrigation system designer or consultant to provide a detailed schedule on the irrigation plan indicating minimum zone pressure and zone components for each irrigation zone. So, and it helps contractors when you're bidding too. Okay, so now we're going to talk about lawn irrigation in a little bit more detail. Determining the irrigation requirements. Okay, areas to be irrigated. That means how many square feet of lawn are you going to have to irrigate. Then you're going to have to do the math to develop your pipe size and for volume and pressure. So if you have a point of connection that's delivering 20 gallons a minute, my recommendation to you is design that system for 15. You can get fooled by the city water commissions because they can move the water source like the storage tanks or whatever their pumping stations. They can change them from neighborhood to neighborhood, and you can see a change in pressure if they need to divert more water to one area than the other. Then you're going to see some pressure changes coming out. You never take your water off the house water. It always is a cross connection from the meter or from the wellhead, never going through pressure tanks. You have to have a clean connection. That's what I call a clean connection. You're not going through any other device. Okay, so then we got to talk about, okay, what kind of grass are we going to water? And I think most of you, I don't have to explain to most of you that are in this webinar that we have cool and warm season grasses, and most of you should know those different types of grasses. But that said, you have to know which type of grass you're watering, because that is going to determine really how you irrigate that site and with what type of sprinklers you're going to irrigate it. So you want to consider your water supply. You need, as you do your design, you want to do the design to the water supply, not the other way around. And then also you got to take into considerations as you're laying things out and figuring things out. You want to take into considerations the climatic conditions of the site. How much shade, how much sun exposure, are we on a slope facing south or slope facing north, etc. Okay, engineering the lawn zone, determining the best system. And so what's going to be best for your system? Is it going to be rotors? Is it going to be sprays? Is it going to be subsurface drip? And there's your spray, which I don't use these anymore, but some people still do. They like them. But they cannot operate above 40 psi. Okay, and then here's your rotors right here that are covering big areas, and you can see the stream there. Those streams are going off probably 30, 40 feet. And then, of course, subsurface irrigation. Now, subsurface irrigation for people on the East Coast is probably not a bad idea, mainly because you get enough water during the summer and early part of the summer that you can get the lawn established without putting in a temporary sprinkler system, so that you can water the lawn in till the roots get down to where the subsurface drip is. But this is an excellent way to save water because it reduces your environmental transpiration rate significantly. And of course, the water's down here where the roots, it's not on the surface and doesn't have to drain down into the root areas. All right, things to consider when we're designing it. That was a particular subject that I wanted to skip over real quick because I wanted to get into this particular subject with the drip systems. Engineering your drip system for high efficiency. Again, you can see the subsurface drip tube here, and you can see how the water percolates around the tube, and you have emitters. These can have emitters every 12 inches, every 18 inches, every 24, 48. So you can design a subsurface system for lawns and for your plants that is low maintenance and delivers water right to the root zone. And then here is a particular garden. You don't see any tubing in there or anything because all of the tubing in this particular garden right here is subsurface. Okay, and then this is your standard drip tubing. You know, we all seen this with the 1/4-inch tube, and you see this tubing lying all over the ground. And if it's not installed properly with enough pins, it can start looking a little messy. And then this is what your roll of tubing, subsurface tubing, looks like. And you can see these little black stripes in this tubing. Those are your emitters. They're self-flushing. They have an air relief built into them. So the technology on the subsurface drip irrigation has come up really, really good. And so this is a typical drip irrigation layout using the tubing. And you can see each one of these triangles is an emitter. So this system down here with the ground cover area, this would probably be all subsurface drip, and then you get into a bed like this, and you might put emitters in here. By the way, you can stick emitters onto the subsurface drip tubing, so you can add more to it if you want. You just have to make the calculations to when you're going your runtime for how many emitters you have on that particular section. All right, typical subsurface layout. Here we go. This is what your typical irrigation subsurface drip system should look like. And this could be a ground cover area here or a lawn or whatever you're looking at. If you use the air relief and the flush valve line that already has that built in, you don't need to put these other devices in. So previously we talked about soil types. And I'm going to emphasize soil types again because when irrigating, you really need to know what kind of soil you're working for so that you can install the right type of irrigation for that soil. So here I've got this chart right here which shows these infiltration rates in inches per hour for different types of soils and the percent of slope. So as you can see here, clay is the least, you have the smallest infiltration rate on your clay soils. So you have to water at smaller increments more often through the day in order to allow the soak and cycle, what we call soak and cycle, so you can allow the water to soak into the ground in a slower rate. And of course, you see on loam, now sand is another problem because the soil just drains through it so fast, then it doesn't retain enough water, so you're going to have to water more often. So amending sand soils or getting sand out of there and putting in loam or compost is compost holds water. So that's a much better way to amend the sandy soil if you have it. And then you see over here how this works on this chart over here. What's your soil type? You can see over here how this works with the different pipe, 18 to 24 inch, 16 to 22 inch, and then 12 to 16 inches, and you're 4 to 6 inches below the soil. So moving along, okay, so xeriscaping, and this is a term that's been bandied about for quite a few years. I remember 20 plus years ago, xeriscaping being something that people were using, or a style of landscaping that people were using. And xeriscaping's come a long way from the original concept. Of course, xeriscaping is from the Greek word xeros, which means dry, and scape from the word landscaping. So it's been used to describe water conservation as a major objective, and that's basically how I use xeriscaping, is to conserve water. It's an attractive and sustainable landscape that conserves water. It could save 20 to 50% in outdoor water use depending on your previous water use habits. The initial cost for xeriscape will probably be slightly higher due to cost of plant material, because some of these plants you'll be using are natives, and so natives tend to be a little bit more expensive because they're harder to cultivate, and there's just not that many people growing them, so supply and demand is pretty much drives the price on that. The savings in irrigation and maintenance and cost makes it cost effective. In about 4 to 5 years, you should have a pretty good return on your investment for doing that. So my thing is plan and design comprehensively, evaluate soil, improve it necessary, create practical turf areas. So don't use, a lot of people like to put, especially out here, put a lawn in the front yards, and all it's there is for greenery. It's not, people don't use it. No one uses the front yard in this area. So if you're not going to use the lawn to me has to be practical and functional, because it requires a lot of water to keep it green. So if you don't have a functional use for it, and you just want to put it in or aesthetic, keep it small, and use a lot of plants to accent or ground covers or other types of attractive plants to accent that little small lawn area if you have to have it. And use appropriate plants, which I've mentioned before, native and local grown. Water efficiently with the most current technology, which is what we've talked about in the previous slides with the smart controllers and the soil moisture sensors, etc., and the subsurface drip tubing. And lastly, but not leastly, organic compost is really, really important. I use a ton of it on every job, and that actually helps me feel confident that the plants that I do plant and water are going to be able to hold up well. The soils get the micronutrients they need, but most importantly, that compost helps retain water in the soil. So when you're designing your planting plan, make sure that you get the soil amended 4 to 6 inches with compost, and that's really going to help your water conservation. Okay, so moving right along here. Now, what is ET? Now, in order to calculate and engineer your irrigation system properly, you want to calculate your ET correctly. So we use a term called ETO. Why this is doing that, I don't know why we're hang on a second, let me see what we're doing here. Okay, for some reason my mouse is going weird on me. Okay, what is ET? So water needs of plants by individual species. So environmental transportation rate is very important for you to calculate. Here's a particular chart here that shows a particular area out in here and where the ET is in particular days. The Weather Service can give you your ET rate. Your local water commission can give you your ET rate. But this is something that the smart controllers calculate for you, and that's why I love them. Okay, moving along here to our next plant. Okay, so calculating. This is the formula that they use for calculating plant ET, and I'm not going to get into that on a very in-depth thing here in this seminar. We don't have enough time, but by using this math and using the ETO calculation, you're going to be able to actually give the plant exactly the right amount of water it needs. So moving to the next slide, historical ETO. Now the Rainbird ESP SMTE controller, smart controller, has a chip on board that gives you your historical ETO for that particular zip code. So you punch in your zip code into the controller, and it tells you exactly, it gives you the exact historical ETO for that particular area. Okay, how to use the ET to program a controller. Now that said, if you're a contractor, this is extremely important for you. If you're a designer, you need to understand this. You don't need to necessarily practice this, but you need to understand it when you're actually calculating out your sprinklers for your site. In other words, if you have a really hot zone, you're going to need to know that. So I'm sorry about my mouse. I don't know why it's behaving so rudely here. So therefore, if your transportation rate is 0.25 inches per day, this is the amount or depth of water that needs to be replaced by the irrigation system. So I wanted to state that one particular deal here. Okay, so now this is the math that we should use for calculating this particular ET for this particular design. And you can see here how these formulas really can help you understand how your irrigation system is going to work. Okay, so now we're going to be out. We're out in the field. Let's say we're out in the field, and we're going to do a little drawing so we can try to calculate. So when we go back to our office, we can calculate what we got to do for the sprinkler system. So we're doing measurements here. We're drawing in where all our sprinklers is. We're drawing our precipitation rate for each one of these sprinklers in here. So as we draw this little design out here to calculate what we're going to do here. Okay, so you can see we have a precipitation rate. So if you go back and use those formulas that I showed you in the last slide, you can actually you have your distances here, and you have your precipitation rate for each sprinkler. And so you do the math on all this, and this will tell you exactly how you should be running your irrigation system for that thing. Okay, so base schedule index. This is something that you need to understand. You necessarily don't need to use it, but it's really helpful to understand it. And so I've got something in here, I've got something in here that talks about the historical ET exist, and here's the rainbird.com and their 800 number. And the other thing I want to recommend, you can always contact your extension service or your local water authority in order to find out what this data, to get some of the basis of this data. Okay, so we've finally ended up to the end of our seminar, and well, I want to go back and kind of review things, what we've learned today. We've talked about soils and how important soils are into engineering your irrigation system. We talked about the different types of sprinkler systems and rotors and so forth that are out there, and MP sprays and so forth. And I would highly recommend you to get as educated on these different types of sprinklers, and especially the current technology in sprinkler irrigation, because the more you know about this, and they're coming out with something new every day, the more you know about this, the better you're going to design. We also talked about the calculations you need to do for pipe sizing, and especially for your using a well or so forth. You have to know how many gallons per minute you have available, so what your water source is, and how you're going to use that water source the most efficiently. And if you don't have enough water, are you going to be able to build a system where you can store water for use in the landscape? And then, of course, we talked about being able to make sure that you do your landscape planting plan first, calculate all of the water requirements for each plant prior to your actually going in and doing your drafting on laying out your irrigation system. There's a couple things that I want to mention to you all that if you aren't aware of, I'd like to make you aware of them. I'm really, like Penny said at the beginning of this, I'm really big on sustainable landscaping, but I'm also big on environmental issues. And one thing that concerns me is putting all this polyvinyl chloride piping in the ground. And I've read something a while back where this piping, polyvinyl chloride piping, is going to start breaking down in 500 to 1,000 years, is when they estimate. And it's going to be off-gassing. It's already off-gassing now, but it's going to be off-gassing very heavily as it gets to its half-life. So we have switched over to a product called Blue Lock, and it's made by a company in Utah called Hydro Rain. They also have a brand that you see in Home Depot or something called Orbit. But they make Blue Lock piping, and they also make PVC fittings that don't require glue. The Blue Lock system, the piping system, comes in 1 inch and 3/4 inch. It's smooth walls, so you get less friction loss. But all the fittings that puts the pipe together are glueless. They all snap in, so you don't have to have that toxic glue out on the site. How many times have I accidentally knocked over a can of glue or primer, and then you don't get these chemicals. You're not breathing the VOCs off of the chemicals. So I strongly recommend all the designers to look into this and specify this on your plans so that we can stop using polyvinyl chloride and we can stop using all these glues. And I really would hope that everyone viewing this would consider what I'm suggesting here. Okay, so that's basically a wrap-up of what I'm talking about. So I'm going to take questions or answer any questions that may be out there.
Okay, we do have a few questions for you, Gary.
Sure.
The first is, are there nationwide initiatives to allow gray water use since gray water is not allowed in all states?
There is initiatives. I believe that Planet, which is now a National Landscape Association, they changed their name again, but I believe that they had an initiative in to do that. And I know that some states, the landscape associations in some states are pushing for that. Now, here in Oregon, they encourage you to use gray water. California, same. But I think using gray water is a great idea if it's engineered and installed and constructed correctly.
Okay, thank you. Is there a definition for the difference between, you mentioned bioswales, vegetative catchments, and rain gardens?
Yes. Okay, a bioswale, and sometimes they're called retention ponds or settling ponds. You know, the different parts of the country have different names for them. But a bioswale is where you're going to dump your storm water into this bioswale. The bioswale will have vegetation in the swell and around the perimeter of the swell, and allows the water to settle out. The plants help take care of the pollution, all of the bad stuff that gets washed into that storm water. The plants help break that down, and the water eventually settles out into the native soil, and it leaves behind residues in the bioswale that the plants then break down. So then you have rain catchments. So those are rainwater harvesting systems that you'd hook to your downspouts or you're hooked to your drainage systems, and you'd have tanks that store it. And some of these systems have filter systems on it, so you get all the gunk out of the water prior to its going into the tank, and then it's pumped out of the tank clean that way. And then you have your roof gardens where your watering for your roof garden is a lot of times is done by catching water that falls on the roof and storing it on the roof and then using it to water the roof garden itself. Otherwise, you're going to have to pump water up that building into those plant beds you have on that roof. So so there are different systems out there that can catch that water as it falls on the roof. And if you have a large enough roof, you should be able to catch enough water even in marginal areas where you could probably not have to supplement that water unless it gets, severe. Any other questions?
Yes. Do you have any tips for discussing the planting plan with your irrigation contractor? And specifically, the question is asking if you have any tips for how to avoid problems.
Okay, yes, I can help you with that. So basically, if you're a designer and you're designing a planting plan, and so let's say it's sold to the client, and the client begins the construction, and the designer goes out there, and the contractor and the designer don't agree on where the plants go. Well, the irrigation plan is pretty much dictating where those plants are going to go based on the planting plan. Because that's where you're going to run your pipe and so. So the contractor says, oh, this is not a good area to plant plants in. There's nothing wrong with revising that plan accordingly, and I found this to be both a designer and a contractor, that the designs don't cover every scenario. It's on paper, and it doesn't translate always to the real world. So the designer has to be flexible enough to take some feedback from the contractor if the designer knows the contractor has a sufficient expertise, and work with that contractor in order to amend the contract or revise the plan slightly so that that issue that the contractor brings up is addressed. Usually I find, even when I do my own designs, I find when I go out there to build it, I run into obstacles and I have to make a change. So my whole thing is adapt for both the contractor and the designer. Learn to adapt.
Okay.
I hope that answered the question.
Yes, thank you. The next question is about negative space that you mentioned early in the conversation.
Correct.
This question relates to when you're talking about planting as few plants as possible, is there a trade-off between not shading the root zones where you would typically be planting with a thicker planting strategy?
Well, I've heard that argument before, and if you're mulching the ground after you put plants in, especially if you're mulching not with bark or pine needles, but if you're mulching with compost, you're going to be able to retain soil moisture as if you had a vegetative cover on that. The thing being is that you can always add more plants, but if you add too many plants, all it's going to do is hurt the client, because in 4 or 5 years they're going to have to be taking plants out. And believe me, I have worked on a lot of landscapes that other landscapers built, and they stuck plants everywhere. And 8 years, 10 years down the road, the client's calling me saying, we need to redo my landscape. It's like a jungle. So what I've been finding is that if you start out as a minimalist and do the minimal amount of planting that you really need to do to make to create an aesthetic, attractive landscape, year 2, year 3, you can go back in and add more plants. And now this is a good strategy for the installer, the contractor, because that gives them an opportunity to go back to that client and maybe do some upsell and get a job planting more plants for them. So you maintain that relationship with the client as their landscape grows out, you're still involved with that client, helping them with their landscaping, adding new plants, or maybe even adding new features. I've had clients come back in, we put some more plants in, and they said, oh, by the way, we'd like to add lighting now. So it's smart business, and it's smart for the ecology of the landscaping.
Okay. This next question is a follow-on to that. How do you convince homeowners of your minimalist planting strategy?
Okay, so run that question by me one more time, Penny.
How do you convince homeowners that you are going to be planting with a minimalist strategy?
Well, here's what I do, and it's pretty much what I've already said. What I do is I take them the planting plan. Okay, that's the first thing I do, and as soon as I get that done, I'm meeting with the client and we're going over it. So the client says to me, well, do you think we have enough plants? And I say, at this point, because I want to keep your budget reasonable, and that I want to be able to see, I want you to be able to live with this for a little bit before you decide that you want to expand on or spend more money on the landscape. So it's advocating, it's empathizing and advocating on behalf of the client so that they don't spend more money than they have to spend, and you don't create a situation for them where they're going to have difficulty maintaining it, or the cost of ownership is going to be very high. So this is what I tell them. I want your cost of ownership to be reasonable. I want you to be able to have a good grasp on maintaining this and not have it get out of control. And I want to be able to save you money on when we construct the landscape. Now, that said, next year, if you want to add more plants, I'll come back and stick more plants in. If you want to spend more money and add more plants, I'll come back and add more plants for you. But live with this for a while and see how it feels. 9 times out of 10, they buy into that 100%.
That sounds like a great strategy.
Thank you,
The
Patty.
question is, you mentioned that you don't turn off the irrigation systems because they sense temperature. Is that because you are landscaping in an area that does not have freeze cycles?
Okay. That's a good question, actually, and I should have addressed that when I mentioned it. So I'm glad whoever asked that question, I'm glad they did. Basically, it just depends on the part of the country you live in. Like here in Oregon, our freeze zone is 18 inches. In New England, your freeze zone might be 24 inches or more. So in that case, you have to winterize your system. It's not necessarily not turning the clock off, but you have to turn the main line off. You have to drain the main line. In some cases, you have to blow out the main line. So it's more involved. If you live in a very cold climate that has temperatures below 0 in the wintertime, then you're going to have to take a different approach to winterizing your system. If you are not in an area that is that heavy, if you're in the southeast or the southwest or the northwest or the west coast, that's not an issue for you.
Okay, thank you. The next question is about the changing water pressure. You mentioned that
Right.
municipal water supply sources vary the water pressure.
Yes.
The question is, do these smart water systems automatically adjust for the reduced water pressure?
No, that's getting a little bit ahead of where the technology is at. I wish they did. But if you understand the engineering of piping and water through pipes, you'll understand that you have a certain amount of pressure coming out of your point of connection, whether it be a wellhead or a meter, water meter, where you're making a cross connection. Okay, a cross connection, in case you don't know what that is, I was making an assumption that most people would know what that is, but I'll explain that real quick. It's where you cut the main line, main water line, you put a connection in there, and you run that connection out to a backflow device. Every irrigation system is required to have a backflow device, and that should be in the design and specified the size of that backflow device, depending on your size of your main line, and the flow that you need to have through that device. So you have to size your backflow device, whether you use a double check device or an RP device or whatever. You have to that has to be sized accordingly, whether it be 1 inch, 2 inch, etc. That said, the water pressure coming out of the point of connection is what it is. We can't control that. We can if it's a well, only to a certain point, because a well can only produce so much. But the city, you can estimate your pressure and your flow from the city connection, but it can change slightly. So when you're evaluating that, and you say, well, I did a test on there, and it showed us that we're getting 20 gallons a minute with a flow meter that you put on the line. And so it's smart to design that system for 15 gallons per minute. Now that said, if the system says, if the pressure regulator that you put on the line for testing says that you have 80 psi, you have to drop that down to between 40 and 60. And then again, you have to drop it again to the drip zone. That has to be no more than 30 psi for the drip zone. Unless you have a lot of drip sprays, then you can be about 40. So in order to control that accurately, you either need to put pressure regulators on the system before the valves. The pressure regulator you put on the drip system is downstream from the valves. So it's after the valve as it's coming out the lateral line. You'll put that pressure regulator there. Rainbird has one that's also a Y filter and a pressure regulator all in one device that you can thread on to the water as it comes out of the valve. And with those Y filters, if you have any grit or any kind of contamination of water, those Y filters will keep that clean. Additionally, those Y filters can also take water-soluble fertilizer tablets. But pressure regulation is really the most important thing in conserving water. Because if your pressure is too high for the nozzle, and you have to look at your nozzle charts to see what working pressure you have to have, which is your dynamic pressure. So if you have static pressure at 80 psi, you want your dynamic pressure not to be any more than 60. And so using pressure regulators, pressure reducers, not regulators, that's what you use for the house. Using pressure reducers that are designated at certain pressures, either 40 or whatever, putting those in line, or using pressure regulated sprinklers. The rotors, Rainbird's rotors and spray bodies all can be bought as PRSs, for pressure regulated. They have a pressure regulator built into the body. So the most important thing, and I can't emphasize this enough, is make sure you're able to get your pressure at the correct dynamic pressure for this type of sprinkler and drip system you're using. Is there a follow-up question on that or not?
No, that takes care of that one. We just have a couple of questions remaining.
No problem.
You mentioned the importance of using compost in water conservation strategies. How much compost are you applying annually?
Okay, so basically when you are constructing a landscape, you're going to want to work into the soil about 4 to 6 inches of compost. Okay, so if you have a heavy clay soil, you'll want to work 4 to 6 inches of compost into the soil, approximately. Then you'll want to lay at least 2 or 3 inches of compost, just straight compost on the ground if you're laying sod, and just rake it out, roll it out, get it nice and level, and then put that down. Or if you're doing seed. And that way the grass first roots out in the compost. It's full of mycorrhizin and all your different microbes and your beneficial funguses, etc., like mycorrhizin. That roots out into that, and then it roots down into the soil that's mixed with amended soil, the native soil amended with compost. Then it roots out down in there. What you want to do on your turf, you want to get at least 4 to 6 inch root zone. So if you dig that turf up, you should pull that turf up. You see all these nice long stringy roots coming off the turf. If you have that, then the turf is feeding correctly. It has enough feeding roots in order to take up the nutrients in the compost and whatever fertilizers you put down. when it comes to planting, you've got planting plants, shrubbery, trees, whatever. You've got two choices. One, you can amend the whole entire site down to 12 inches, down to 12 inches, and then plant all your plants. Or you can actually dig a very nice size hole, fairly deep, put a bunch of compost and amended soil into that hole and plant your plant. That plant will eventually grow out into that hole, and then if you mulch with compost, all of those nutrients, those micronutrients and microorganisms are filtering down into the clay soil and will eventually release the colloidal particles in that soil so that you get water down there and it'll hold water. So if you have a bucket of compost and a bucket of dirt, put water in the bucket of compost and put water in a bucket of dirt and leave them out in the sun, and then put your hand in there and see which one is the wettest. I think that's going to convince you compost holds water and can help you with water conservation.
Great. And we have just one question remaining. You mentioned the importance over time of the glueless tubing. Can you tell us who the manufacturer was and recommend where we can get more information?
Yes. Okay. So if you want to get away from using PVC pipe and glue and primers and all that nasty stuff, you'll want to contact HydroRain in Utah, hydrorain.com, and you'll want to find out where a distributor is in your area to buy it.
Okay.
Now, what I wanted to advise everybody, because you have to understand this when you're using these different technologies, these newer technologies. They're more expensive. I'm going to tell you that right up front. Your cost of your your blue lock pipe, the polyethylene pipe, and the fittings is about 300% more than you would if you were using PVC. Your labor savings is 600%. I'll give you a good example. I installed, by myself, 2 irrigation zones having 5 sprinklers on each zone. And I had to extend the main line over to the valve. So I installed a main line. I installed 2 valves, the valve boxes, did all the trenching, put in 10 sprinklers for 5 each for 2 zones, covered up the trenches back up, and had the nozzles installed and everything in 3 hours.
Impressive.
So, as you can see, on that job, I charged that lady $1,800 to do that job. I made $1,000.
Very good.
So, I don't care how much it costs, how much the materials cost. Doesn't matter to me. It's how much labor I'm saving, and the fact that I'm using a product that's not harming the environment. So it's a win-win.
That's excellent. Well, thank you, Gary, for all of this very valuable information. Certainly with the heat of summer upon us and dry conditions already plaguing much of the country, this is certainly going to be very helpful information for all of us.
Yeah, I hope that everyone that attended this has learned at least one thing new today. And my email and my phone numbers here if anybody wants to contact me directly with any questions.